Hey everyone, and welcome back to The Explainer. I am absolutely thrilled you're here today because we are finally tackling something that sits right in front of us literally every single day, yet somehow constantly manages to intimidate us. We are breaking down the complex, honestly kind of confusing world of tech specifications and acronyms. By the end of this explainer, you are going to be totally fluent in the secret language of your digital devices.
Have you ever felt completely lost in this tech alphabet soup? You know the feeling. You go to buy a new computer, or maybe you're on the phone trying to troubleshoot a wonky internet connection, and suddenly the person on the other end is just throwing out three-letter acronyms like they're going out of style. It is incredibly frustrating. It feels like they're speaking an entirely different language. But today, we're going to decode that language together.
To make sense of all this, we're using a layer cake approach today. We'll start with Layer 1, the physical machine. Then Layer 2, connecting to the world. Layer 3 covers the invisible instructions. And finally, Layer 4 will look at the automated future.
Okay, let's dive into Layer 1, the physical machine. This is the hardware and storage you can actually put your hands on.
To really wrap our heads around computer hardware, I want you to picture a bustling, high-end restaurant kitchen. Everything inside your computer's physical body plays a very specific role in getting a meal prepped and out to the dining room. First up is the CPU, the central processing unit. In our kitchen, the CPU is the absolute head chef. It stands right in the middle of the room, executing all the main orders, shouting out commands, and handling the most complex calculations. Basically, if the CPU is slow, the whole kitchen grinds to a halt.
Now, right next to the head chef is the GPU, or graphics processing unit. You can think of the GPU as your highly specialized pastry chef. It doesn't manage the whole kitchen, right? Instead, it specifically handles all the heavy visual lifting. So when you need an incredibly detailed, beautifully rendered image, like if you're playing a high-end video game or rendering a 3D animation, the GPU is the specialist that steps in to make sure it looks perfectly smooth. All right, moving on to memory. We've got RAM, which stands for Random Access Memory, and ROM, Read-Only Memory. Think of RAM as your quick access kitchen countertop. It's the workspace the chef is using right now for current tasks. The bigger the countertop, the more ingredients they can chop at once without slowing down. ROM, on the other hand, is the permanent recipe book sitting up on the shelf. The computer uses ROM just to know how to turn on in the first place. You read it, but you don't mess with or rewrite those foundational recipes.
So where do we store all the extra ingredients? Well, that brings us to storage. The HDD, or hard disk drive, and the SSD, the solid-state drive. Both of these act as your deep storage pantry. But listen, this is absolutely crucial when you're buying a new computer. An HDD uses an older mechanical spinning disk, while an SSD has absolutely no moving parts whatsoever. Upgrading to an SSD is literally the difference between waiting 30 agonizing seconds for your computer to boot up and it blazing to life in just 3 seconds. It's a game changer.
Just to quickly wrap up our physical layer, let's hit a few hardware essentials. You've got the USB, the Universal Serial Bus, which is how we plug external tools and ingredients into our kitchen. There's the BIOS, or Basic Input-Output System, which acts like the morning alarm clock, waking the machine up and checking the hardware. And finally, the LCD. Liquid Crystal Display, or LED, light-emitting diode. Those are just your screens. That's the plate where the final, beautifully cooked meal is actually presented to you.
So that's the hardware. Let's move to Layer 2, connecting to the world. Networking and the internet.
Now that our kitchen is up and running, we actually need to reach our customers. First, we need to understand the scale of our network, which means looking at LAN and WAN. LAN is your local area network. This is small-scale stuff. It connects devices in your single home or your specific office building, kind of like the waitstaff moving through one single restaurant. But a WAN, a wide area network, covers massive geographical areas. The internet itself is the ultimate wide area network, connecting LANs all over the globe like a giant international delivery fleet.
When you step out onto that massive WAN, you need some identification. Your IP, or Internet Protocol, is your device's public address on the network, so data knows exactly where to find you. But what if you want a little privacy? That is exactly where a VPN, a virtual private network, comes into play. A VPN acts as a secure, private, encrypted tunnel that completely hides your real IP address from the rest of the network.
Now, what's really fascinating here is how these next 4 acronyms team up to actually bring you a website. HTTP stands for Hypertext Transfer Protocol, and HTTPS is just the secure version of that. Think of them as the delivery trucks transferring data back and forth. The URL, or Uniform Resource Locator, is the exact street address of the website you want to visit, and HTML, the hypertext markup language, is the actual building material. It's the code language that physically builds the visual web page you end up looking at.
Let's actually put this into a real-world mini-narrative. Think about the journey of a single click. Step 1, your device uses Wi-Fi, wireless fidelity, to connect to your ISP, your internet service provider. Step 2, your ISP queries the DNS, the domain name system. The DNS is basically the phone book of the internet, translating a website's name into a computer-readable address. And finally, Step 3, you're granted access to the www, the World Wide Web. And you know what's crazy? All of that happens in the literal blink of an eye.
Moving right along to Layer 3, the invisible instructions. This is all about software and programming.
Here's the catch. None of that incredible hardware or networking means a thing without our third layer. It all starts with the OS, the operating system. The OS is the foundational software manager. It is the big boss controlling all the physical hardware we just talked about, and it provides the stage that allows all your other programs and apps to even run in the first place. But computers speak in ones and zeros, right? And we definitely don't. That is why your operating system uses a GUI, a graphical user interface. The GUI is a translator. Much like a restaurant host translating your menu choices into a shorthand the kitchen understands, the GUI takes all that incredibly complex back-end code and translates it into those simple, colorful visual icons, folders, and windows that we just intuitively click on every single day.
Once we're clicking around our interface, we manage data constantly using specific formats and languages. A PDF, or portable document format, is universally used for a reason. It perfectly preserves your document's text and formatting, no matter what device you open it on. On the flip side, when we're dealing with massive amounts of data, back-end systems use SQL, structured query language, to easily search, extract, and manage information housed inside gigantic databases.
And this brings us to a concept that brilliantly illustrates how this invisible layer truly connects everything: the API, or Application Programming Interface. An API is essentially how different software programs talk to each other in the background. Think about when you open the weather app on your phone. Your app isn't physically going outside to check the temperature, right? It's using an API to silently request and pull that data directly from a massive meteorological service, delivering it seamlessly right to your screen.
Finally, let's step into Layer 4, the automated future. Let's decode the terminology of tomorrow.
We've covered the machine, the network, and the instructions. But right now, we are experiencing a massive transition. We're moving away from static software where computers just sit there waiting to follow our strict line-by-line instructions, and we're moving toward automated, immersive technology. We are literally entering an era where computers can actually think for themselves and create entirely new environments for us to step into.
The heavy hitters driving this transition are AI and ML. AI stands for artificial intelligence. This is the broad, overarching concept of creating machines capable of simulating human intelligence and problem-solving. ML, or machine learning, is a very specific subset under that AI umbrella. Machine learning is the process where machines are given vast amounts of data so they can learn, recognize patterns, and improve their performance entirely on their own, without us having to explicitly program every single step.
And how are we actually going to experience this new computing era? Largely through VR and AR. VR is virtual reality. When you put on a VR headset, it totally blocks out the real world and drops you into a fully simulated 360-degree digital space. AR, or augmented reality, is totally different. AR takes digital elements, think data, navigation arrows, or 3D models, and overlays them directly onto the real physical world you're already looking at through your screen or smart glasses. So, we decoded the kitchen, we've connected to the web, translated the instructions, and peeked into the automated future. You now have the foundational knowledge of tech terminology. But as we know, technology never, ever stops moving. So I want to leave you with this question. How will you use this new vocabulary to confidently navigate tomorrow's inevitable wave of new acronyms? Because the future is being coded right now, and today, you finally speak the language. Thanks so much for joining me on The Explainer.